Welcome back, students, to another class in physics. Today we'll be introducing a new topic from the syllabus of physics in class 11, vectors. In physics, we study about large number of physical quantities which are broadly classified into two categories, scalars and vectors. Scalars are those quantities which have magnitude but no direction. For example, mass, length, time, work. Vectors are those quantities, those physical quantities which have both magnitude and direction. For example, velocity, acceleration, momentum, and force. Graphically, a vector can be represented by a straight line with arrowhead on it, that is, an arrowed line. Here, the length of the line, as you can see in the picture, the length of the line drawn on suitable scale represents the magnitude of vector. Then what about the arrowhead? The arrowhead tells the direction of vector. The starting point of arrowed line is called tail or origin of vector, and the end of the arrowed line is called tip or head of the vector. In writing, a vector can be represented by a single letter with arrowhead on it. Like for example, vector A can be written as this. Suppose force, which is a vector quantity, if I want to represent it in vector notation, then it will be written like this. Vectors can be divided into two types: polar vectors and axial vectors. Polar vectors. These are the vectors which have a starting point or a point of application. For example, displacement and force are polar vectors. Axial vectors. These are those vectors which represent a rotational effect and act along the axis of rotation in accordance with right-hand screw rule. As you can see in the picture, it is quite clear that there is an axis of rotation, and about that axis we can figure out an axial vector. Now this axis of rotation, about this axis there can be an anti-clockwise rotation or a clockwise rotation, both can be imagined, and it is in accordance with Maxwell's right-hand screw rule. Example of axial vectors are angular velocity, torque, and angular momentum. For a vector having anti-clockwise or clockwise rotational effect, will have its directional along the axis of rotation, as you can see in the picture. A very important question arises at this point, that what are the importance of vectors? Now, wherever possible, we express the laws of physics in vector form due to the following reasons. Many laws of physics can be expressed in compact form by the use of vectors. The derivations involving many laws of physics can be greatly simplified by the use of vectors. The laws of physics, when expressed in vector form, remain invariant for translation and rotation of the coordinate system. Now, since this is just an introductory class in vectors, we won't be getting into much of the details. We would be understanding just what are vectors, what are the different types of vectors, and where is the importance of vectors. That will become much more clear when you study more about these laws. Then it will be easy for you to realize the fact that wherein lies the importance of the concept of vectors. Let us begin by understanding a few definitions in vector algebra. To begin with, let's understand what is unit vector. Now, I hope you understand what is unit. Unit always refers to 1. Unit magnitude. A unit vector of the given vector is a vector of unit magnitude and has the same direction as that of the given vector. For example, if I want to write down the unit vector of A, So unit vector will be written as A, and then a notation like this. It is read as A cap or A hat. Now since magnitude of vector A is A, magnitude of vector A is equal to A, so we can write down vector A equal to magnitude, and then for mentioning the direction we make use of this unit vector. So or we can write down from here unit vector to be equal to A vector divided by the magnitude. The magnitude is also referred to as the modulus. Now in some books you will find it is written somewhat like this. Okay, so this is equal to the vector divided by modulus of the vector. This means the magnitude of the vector. Thus, a unit vector in a given direction is also defined as a vector in that direction divided by the magnitude of the given vector. It is unitless and dimensionless vector and represents direction only. So in Cartesian coordinates, we are having three unit vectors: I cap, j cap and k cap. So along x-axis, the unit vector is I cap. Along y-axis, it is j cap, and obviously along the z-axis, the unit vector is k cap, as you can see in the picture. Let us understand how to find out the unit vector in this question. The given vector is 4I cap minus 3j cap plus k cap. So let us try and solve this question. Here, if we assume that it is vector A, then vector A can be written in its component forms as AXI cap plus AY j cap plus AZ k cap. Now every vector has got its components along the three mutually perpendicular axes, that is x-axis, y-axis and z-axis. Now we will be discussing this in a bit more detail in the coming lessons, in the coming sessions of this chapter. But for the time being, you should simply understand that the vector can be represented in the form of its components along three mutually perpendicular axes, as I have written right now. A vector can be written as AX I cap. AX is the component of vector A along the x-axis with the unit vector I cap, plus AY, that is the component of vector A along y-axis with unit vector j cap, plus AZ, that is the component of vector A along z-axis with unit vector k cap. Let us equate it with the given vector, that is 4I cap minus 3j cap plus k cap. So we can easily compare. So on comparing, we get AX equal to 4, AY equal to minus 3 and AZ is equal to 1. Therefore, A will be equal to root over AX square plus AY square plus AZ square. That will be equal to root over 4 square plus minus 3 square plus 1 square. That will be equal to root over 26. 4 square is 16 plus 3 square is 9 plus 1. So 16 plus 9 plus 1, that is root 26. Therefore, the unit vector A cap is given by vector A divided by magnitude of A. So that will be equal to 4i cap minus 3j cap plus k cap divided by root over 26. In this manner, we can find out the unit vectors. Equal vectors. Two vectors are said to be equal if they have equal magnitude and same direction. Like suppose if we are having two vectors, A vector and B vector, and they are represented by two equal parallel lines drawn with same scale having arrowheads in the same direction, then vector A and vector B are called equal vectors, as you can see in the third case. Negative vector. A negative vector of a given vector is a vector of same magnitude but acting in a direction opposite to that of the given vector. Negative vector of A, as you can see, is given by minus of A vector. Minus of A vector is equal in length but opposite in direction to vector A, as it is quite clear from the picture. Co-initial vectors. The vectors are said to be co-initial if their initial point is common. As you can see in the picture, vectors A and B have been drawn from the common initial point O. Therefore, A vector and B vector are called co-initial vectors. Co-linear vectors. These are those vectors which are having equal or unequal magnitudes and are acting along the parallel straight lines. As you can see in the picture, all the vectors are along the parallel lines in same direction or in opposite direction. Coplanar vectors. These are those vectors which are acting in the same plane. As you can see, A and B, they are on the plane of the paper. So they are coplanar vectors. Now let us get some understanding of position and displacement vectors in a plane. Consider the motion of an object in xy plane with origin at O. Let at any time t the object be at point A. Now if we draw an arrow with its tail at point O and held at point A, as you can see in the picture, then OA vector is called position vector of the object at point A. So OA vector is called position vector of the object at point A and is generally represented by vector R. So as you can see in the diagram, I have marked OA vector as the position vector. Now here one important piece of information. What does the position vector OA vector of the object at a point provides? What information does it provide? It provides two important informations. It tells the straight line distance of the object from the origin or the starting point, and it tells the direction of the position of the object with respect to the origin. Now let us go back to the previous diagram. Let at time t dash, now this was for time t, let at time t dash the object reach at point B. The object reaches point B. Then OB is the position vector of the object at time t dash. So here AB AB vector, where tail or initial position is at A and head or tip is at B. As you can see, tail or initial position is at A and head or tip is at B. This is called the displacement vector of the object in time interval t dash minus t. So I repeat here, AB vector where tail or initial position is at A and head or tip is at B is called the displacement vector of the object in time interval t dash minus t. So hence, displacement vector is that vector which tells how much and in which direction an object has changed its position in a given interval of time. So now, if the coordinates of point A and B are given by xy and x dash y dash, then position vector OP is given by x I cap plus y j cap. Now let me correct one thing, this is position vector OA. So position vector OA is x I cap plus y j cap, and position vector OB is equal to x dash I cap plus y dash j cap. So the displacement vector AB is given by x dash minus x I cap plus y dash minus y j cap. Both the position vector and the displacement vector that have been described above are the examples of vectors in a plane or in two dimensions. Now it is important to note that in case of position vector and displacement vector, both the tail and head have definite meanings. Let us go back to the diagram so that it becomes pretty much clear to you. So as I was saying, that it is important to note that in case of position vector and displacement vector, both the tail and head have definite meanings. Whereas it is not so in case of vectors like velocity, momentum, force, because the tip or head of the arrowed line representing position vector or displacement vector tells the final position of the object, but the tip or head of the velocity vector does not give any such information. Thus, the nature of position vector or a displacement vector is different from vectors like velocity, momentum, or say force. We will end our discussion for today at this point. We will continue with the remaining topics in that lesson of vectors in our next session. Thank you.